So last but not least for today, let's get into some expressions using scientific notation. So for this section, it is calculator active, but since you get to use a calculator, you must show the breakdown of the work I show below. So just a reminder, like we did in warm-up in class, scientific notation takes large and small numbers and rewrites them in this form. So the first number needs to be between 1 and 10 times 10 to some power. So let's look at this. We're doing 1.4 times 10 to the 5th, all of that squared. So that's going to be 1.4 squared times 10 to the 5th squared. So that's 1.4 times 1.4 times 10, let's put an X there for multiplication, times 10 to the 10th, power to a power. I multiply. So now for this piece in front, let's see, 1.4 times 1.4, really you don't need a calculator for this, but it doesn't hurt right now, is 1.96. So this becomes 1.96 times 10 to the 10th power, simplified. Same idea here with this scientific notation in number 11, but now we're raising to the 3rd power. So that's going to be 3.67 to the 3rd times 10 to the negative 6 to the 3rd. So that's 3.67 times 3.67 times 3.67 times 10 to the negative 18, power to a power. So now I'll pull out my calculator for this piece, 3.67 times 3.67 times 3.67 is 49.4309 times 10 to the negative 18. So now this is okay, but it's not written in the correct format for scientific notation because this first number needs to be between 1 and 10. So how would I change this number to be between 1 and 10? Well, I would have to divide by 10 to move the exponent to the left, but if I divide by 10 to move my exponent, I have to multiply by 10 here so that I don't change my answer. So now I have my final answer, 4.9431 times 10 to the negative 18 plus 1 is negative 17 power. So when you move your exponent to the, when you move your decimal to the left, that's really dividing by 10. So to not change your answer, you multiply by 10. So we'll practice these in class together.